Hello friends and greetings for today. Welcome back to another tutorial on ISTQB Advanced Level Test Management Certification. We are in chapter 2 talking about managing the product and continuing ahead with 2.3, that is defect management. Today we shall be covering the last segment of this particular topic, that is 2.3.6, defining process improvement actions using the defect report information. And as a part of our previous tutorial, we have already discussed that what exactly defect report informations are, and here we are trying to understand what information can further be added to be used as a process improvement. Well, to just set up some context, of course, there are certain information which we have discussed in our previous tutorials, and we have understood very well that there are specific information to be collected to get some insights about the defect, which sometimes can be with the objective of reproducing the failure, sometimes it helps you to resolve the issue, and sometimes it just helps the organization to improve their ongoing process and the set of activities related to not only testing, but also can be used for development lifecycle as well. Now, indeed, as this thing can be considered as one of the criteria for the defect information being gathered, we would like to understand in a deep dive that what kind of fields can actually help you collect the data which could be useful for determining the process improvement actions. And this topic is particularly for that. Now, to understand how these fields could be very helpful in defining and determining the process improvement, let's get into the deep dive of it. The very first part here to discuss is the set of details directly right here. And the very first thing is, of course, monitoring, controlling, and completion and test reporting. Defect information should support the overall process improvement initiatives as we have discussed during the retrospectives. Now, some of these examples do include like using information about the phase of introduction, detection, and removal of the defects to assess the phase containment and or perform the cost of quality analysis with the aim of suggesting ways to improve the defect detection effectiveness in each phase and minimize the cost associated with the defect. Now, number one thing, you got a new piece of information here, that is what is phase containment. Now, of course, there are three fields if you see: introduction, detection, and removal. Now, introduction is a field which talks about where the defect was introduced. Then detection means, of course, where the defect was identified, and removal means, and finally, which phase we closed it. Now, these the three phases can certainly be different. For example, you would have identified a defect in system testing. Post RCA, you figured it out that it was due to requirement misunderstanding, but you resolved this during UAT. Okay, so it might be possible because there are, of course, many other level after system testing. You might have done it during the non-functional testing as well because the team took a little longer to resolve the issue. Now, when the difference of the phases are there between the introduction and detection, we call it as phase escape. That means defect leakage. So say, for example, a defect was introduced in requirement gathering phase, but detected in system testing. Now, this is what we call it as phase escape. But the word what we had in our passage was phase containment. The phase containment stands for when you identify a defect or detect a defect in the same phase where it was introduced. So for an example, if you had a defect identified during requirement gathering while doing review, and the root cause of that was that it was introduced in the requirement gathering itself, then that's where we call it as phase containment. So it is important to understand that the reason why we are talking about these fields is to increase the number of phase containments and try to reduce the cost of fixing a defect, whereas phase escape is not recommended. So these three fields can help us to improve our activities and also determine what kind of activities are effective in identifying the defects more. The point number 2 here is using information about the phase of introduction for analysis of the phases in which the largest number of defects are introduced to enable targeted improvements for the defect prevention. Other way around, the same field can be used to identify which particular phase has a lot of defects introduced. And if you had a high number of defects introduced during coding, we understand that development has to improve. Right? The same way, if we find a lot of defects were introduced during design, then we understand the design has to be revoked or we have to do something better for it. Let's look at further. So number 3, using defect root cause information to determine the underlying reasons for defect introduction to enable process improvement that reduce the total number of defects, which is again root causes contributing as similar as that of the introduction. But just to understand, phase of introduction and root cause information are two different things. Phase of introduction is about the phase in which we introduced it, and root cause is the core reason. That is, it was implementation of requirement. Was it a code error? Was it a design implementation? So root cause and phase are two different things, right? The next point here is using defect location information to perform defect cluster analysis to better understand technical risk and for some risk-based testing and to enable refactoring of troublesome components. So location is more to understand which particular part of the code has that issue. So we can understand if the code was complex, we can look forward to add more value or more testing in that area to determine or follow the principle defect clustering. The next point here is using information about reopen defects to assess the quality of debugging implementation. So of course, every defect has a life cycle. Reopened is one of the status in that. By having this filtered by the status reopened, you would understand which of the defects or which are the types of defect which we have reopened quite often, and in future we should consider them for regression testing. Or next time when we get some defects related to that area, we would like to be more extra cautious to make sure that they do not reopen again, right? So there could be multiple improvement actions which can be taken just by the status that is reopened. So we just have to have a thought process of deep dive and deep thinking, which would help us. Similarly, using information about duplicate and rejected defects to assess the quality of the defect report creation. So number of duplicate defects certainly helps us to understand that we are raising unnecessary defects, which the team is rejecting. And rejected defects basically means that you have reported the defect, but there was no sufficient information. So we may have to, improve the way we write it and many other things like that. So we look forward to work on duplicate and rejected defects as well and try to reduce them as a part of improvement. The last thing is, of course, enable process improvement that reduces the total number of defects by introducing proactive measures to avoid errors upfront. So the more we try to reduce the number of defects in future cycles, we are actually trying to improve ourselves in a way that we are making our process more effective and efficient in order to meet the quality needs rather than getting engaged and blocked with the unnecessary defects. So put together, the whole goal is to understand that how we can consider the defect information or defect data fields to collect some more information from this and then look forward to define and determine the improvement actions within the process. Finally, to add here, of course, the last important part here to discuss is that in some cases, teams do decide not to track defects found during some or all the phases of SDLC. While this is often carried out in the name of efficiency and for the sake of reducing the process overload or overhead, it greatly reduces visibility into the process capability of the software development and testing. And this also makes the improvement suggestion above difficult to carry out due to a lack of reliable supporting data. So this entire paragraph can be just summarized as that when it comes to the startup organization, which are not well organized, not mature enough to start doing a lot of heavy documentation, they decide to take this informally. For example, if a tester finds a defect, he just or she just drops a text on the chat to the developer that, hey, we found this, can you fix this? But we don't document a defect altogether like defect management tools. So we may just work on emails or chats because at this point, this organization is not ready to do heavy documentation or heavy test management. And that is where they decide not to track some defects or maybe all of their defects. So yes, both are possibility. But the second important thing at the same time is this organization will never have visibility when it comes for them to improvise themselves. That means over a period of time, like after 1 year, 1.5 years, if they want to make a process, they will never have visibility to any such information, which can allow them to determine what needs to be improved. So that is where this is the pros and cons of not managing defects. But yes, being a startup, you don't have a mature process. You will not waste a lot of your time doing that. So you decide to do it offline. But at the same time, this is what the challenges you will face when things are not being managed well, right? So that's where we just wanted to understand that how exactly defect report information can help us to determine what exactly is needed to drive the entire defect management details. So that's all from this particular tutorial, team. Should you have anything else, feel free to comment below. I'm always there to address your queries and answer them well. Till then, keep learning, keep exploring, keep understanding the context. Thanks for watching the video, team, and happy learning.